definition of angular momentum is that it is the quantity of rotation of a body, which is equal to the product of its moment of inertia and angular velocity.
Calm before the storm. Gold.
The formula for our angular momentum is mvr, where m stands for mass, v stands for velocity, and r stands for radius.
Chasing the stars, all that we said, all that we are, waiting to fly. This is the start.
Here we have a long stick, and at each end we have two masses. The black dot is known as the center of rotation because it is the point at which the two masses will rotate around.
Yours and mine, euphoria. Hide and seek, reason and rhyme, grand and glorious. Living the dream, yours and mine.
The distance between the center of rotation and the mass is known as the radius. Because these masses are attached to the stick, they will rotate in a circle, following the path shown. The angular velocity of these objects is the path of which it follows.
Move outside your head.
These masses have a tangential speed, which is perpendicular to the radius.
Strong in every step. Give me a sign. Hitting the mark.
Here is an example
To the sky.
of solving for angular momentum. We have our center of rotation, a radius of 12 meters, an object with a mass of 5 kilograms, and a tangential speed of 7 meters per second.
Hide and seek.
By substituting these numbers in for their variables, we can solve for the angular momentum. 5 times 7 times 12 is equal to 420, and the unit for momentum is kilograms meters per second. But what happens if we decrease the radius? What happens to the velocity? By using basic algebra, we can rearrange the formula to solve for v. To isolate velocity, we take angular momentum and divide it by mass times radius. In this new problem, we have our center of rotation, a radius of 6 meters, the same object with a mass of 5 kilograms, and we have an unknown tangential speed as the radius has changed. By substituting the numbers in for the variables, we have 420 over 5 times 6. 5 times 6 is 30, and 420 divided by 30 equals 14 meters per second. With this, we can see that as the radius decreases, velocity increases. This shows us that radius and velocity are indirectly proportional to each other. The conservation of angular momentum is the same as the conservation of momentum. The momentum in a system will remain the same before and after, unless an external torque or force is applied on it. The conservation of angular momentum applies in space just as it does on Earth. Here we have the sun and an object following an elliptical path.
Jewels behind the throne. Into the night. Out of the dark. Take to the sky.
As the object follows its path, as it gets closer to the sun, its radius decreases, and because of this, its speed increases. The Big Bang, known as the Nebula Hypothesis, is believed to be the cause of our solar system and all the galaxies around us.
Living the dream. Yours
This hypothesis claimed that the primordial nebula, known as our solar system, has decreased in size from 10 billion years ago to 5 billion years ago. This decrease in size assumes that the tangential speed or the velocity of the objects in our solar system have greatly increased. The moment of inertia is a quantity expressing a body's tendency to resist angular acceleration.